Question 1. Explain the meaning of differentiation and what are the techniques of differentiation. So, differentiation is a process in calculus used to find the rate of change of a function. In simple words, differentiation tells us how fast something can changing at any point. The technique of differentiation is power rule, constant multiple rule, sum and different rule, quotient rule, product rule, chain rule, trigonometric differentiation, exponential differentiation, logarithmic differentiation, implicit differentiation, and higher order derivative. Question 2a. For this question, we are asked to find the derivative of the function y equal to tan x cubed exponent of 4x. To differentiate this function, we use the chain rule because the outer function is tan, and inside it we have another function. The derivative of tan u is sec squared u, so we get dy dx equals to sec squared multiplied by x cubed exponent of 4x. Next, we multiply this by the derivative of the inside expression x cubed exponent of 4x. Since x cubed exponent of 4x is a product of two functions, we need to use the product rules, which is uv prime plus uvu prime. So we let u equal to x cubed and u primes equals to 3x squared, v equal to exponent of 4x, and v primes equal to 4 exponent of 4x. On this slide, we substitute everything into the derivative formula. Dy dx equals to open bracket sec squared multiplied by x cubed exponent of 4x close bracket, and then we open bracket x cubed multiplied by 4 exponent of 4x plus exponent of 4x multiplied by 3x squared close bracket. This expression comes directly from the product rules. So next, the terms of simplified equals to sec squared x cubed exponent of 4x close bracket open bracket 4x cubed exponent of 4x plus 3x squared exponent of 4x close bracket. Then exponent of 4x is factored out, so we get open bracket sec squared multiplied by x cubed exponent of 4x close bracket, we open bracket exponent of 4x multiplied by 3x squared plus 4x cubed close bracket. Finally, the simplified answer is dy dx equals to exponent 4x sec squared multiplied by x cubed exponent of 4x multiplied by 3x squared plus 4x cubed.
For question 2b, we are asked to find the derivative of the function fx equal to 3 minus 4x over ln 2x, which is like u over v. Because this is a fraction, we use the quotient rule. The quotient rule states f prime x equal to vu prime minus uv prime over v squared. For differentiate the numerator, we need to let u equal to 3 minus 4x. 3 is constant, so it will become 0. For negative 4x is negative 4 because power will differentiate to constant. And for the denominator, we need to let v equal to ln 2x. Differentiate ln will get 1 over 2x, and differentiate 2x will be 2 because power will be constant. After that, v prime will be 1 over 2x 2. We need to simplify it. So v prime will be equal to 1 over x. Now we substitute the value of u prime, v prime into the quotient rule. So after substitute, f prime x equal to, the numerator is ln 2x negative 4 minus 3 minus 4x 1 over x over ln 2x power square. After substitute, we simplify each part inside the numerator. The numerator have two terms. First term is ln 2x minus 4. The first term will be negative 4 ln 2x. For the numerator, second term is 3 minus 4x 1 over x will be 3 minus 4x over x. F prime x now is equal to negative 4 ln 2x minus 3 minus 4x over ln 2x power square. Now, to combine both terms in the numerator, they must have the same denominator. The first term has no denominator, so we multiply it by x. From the previous slide, we already made both terms have denominator, which is negative 4x ln 2x over x minus 3 minus 4x over x. We must distribute the negative sign across the bracket. Negative, open bracket, 3 minus 4x, close bracket, will equal to negative 3 plus 4x. So, the numerator become negative 4x ln 2x minus 3 plus 4x. Put the expression back into the full derivative and the denominator still the same. So, the final answer is f prime x equal to negative 4x ln 2x minus 3 plus 4x over x ln 2x power square.
Assalamualaikum, my name is Nura Farisha Bijay Nura Fakri. My student ID 2024630688. So I will explain implicit differentiation. The question is x squared plus y plus ln x over y minus 2x equal to exponent 1 of 1 minus 2x. Let a equal x squared plus y. We use ub. A prime equal ub prime plus b prime. Here we use quotient rule. Let u equal x squared, u prime equal 2x. Let v equal cos y, v prime equal negative sine y with respect to x. So we put it dy dx here. So here a prime we will put it back to u v prime plus v u prime. It will become x squared negative sine y dy dx plus cos y 2x equal negative x squared sine y plus 2x cos y dy dx. Let b equal ln x over y equal ln x minus ln y. So b prime will be 1 over x minus 1 over y dy dx. Let c equal to 2x, so c prime equal to 2. Let d equal exponent power of 1 minus 2x. D prime equal negative 2x exponent 1 minus 2x. So here we put the derivative into the equation back. So it will be x squared sine y plus 2x cos y dy dx plus 1 over x minus 1 over y dy dx minus 2 equal negative 2x exponent 1 minus 2x. We factor out the dy dx and the others that we didn't want. We will put it into the left side. So it will be dy dx 2x cos y negative 1 over y equal negative 2x exponent 1 minus 2x plus x squared sine y minus 1 over x plus 2. So here we put the right term into the left side because we only need dy dx here. So dy dx equal to negative 2x exponent 1 minus 2x plus x squared sine y minus 1 over x plus 2 over 2x cos y minus 1 over y.
Assalamualaikum, my name is Nur Balkis Kasina binti Baharudin and so for the function definition, fx equal to 2 over cube root x plus ln x, and for the calculation, we use fx naught equal to f64 equal to 2 over 64 power of 1 over 3 plus ln 64 equal to 4.658883083. So for the step 2, I need to find the f prime x naught. Okay, so for the step 3, use the formula which is the linear approximation formula. So f of x is approximately equal to f of x naught plus f prime of x naught times the quantity x minus x naught. So for the step 2, substituting the value, f of 64.02 is approximately equal to f of 64 plus f prime of 64 times 0.02. So for the calculation, f of 64.02 is approximately equal to 4.658883083 plus the quantity 5 over 384 times 0.02. So for the final answer, which is approximately equal to 4.6591.